Right? Alright, so yesterday we plotted these points on here. 1, 1, 2, 2. Faith, you ready to listen?
What?
Oh, it's not Faith. Is it Jessica that was talking?
Yep.
Jessica. Alright, so we plotted those points on there, and you guys drew a line of best fit, however you thought was best. Some people drew this line right here, connected those two. Some people drew this line, connected those two. Some people drew that line, connected those ones. But there were a whole bunch of different lines of best fit that you guys drew. Right? And every one of you that drew that, you could use that to predict a certain line value. Now, remember what I told you yesterday? Is that the right way to find your line of best fit? No. That is not the right way to find your line of best fit. Okay? We are going to learn that right way today. And part of teaching you why this is not the right way is figuring out the sum of our residuals. Alright, so someone tell me what they have for the predicted y's right here. Just raise your hand. Raise your hand. Predicted y's.
What? What did you say?
What do you have for your predicted y?
Oh.
We filled this. What do you have, Faith?
1, 2, 3.
1, 2, 3. So I'm guessing your line looked like this. Okay. So then the residuals were
0, 0, 2.
0, 0, 2. So what's the sum of your residuals?
2.
2. Out of all the residuals, I got 2, right? Now, when you guys told me about line of best fits yesterday, you said that the line of best fit is the line that goes through the middle of all the data, right? Does that line go through the middle of all the data? No. Okay. Middle means we have equal parts on both sides, doesn't it? Do we have equal parts on both sides right here? No. Okay. So that is not the middle, is it? Okay. And what indicates the fact that we don't have equal parts on both sides is the sum of the residuals. Right? That's going to be important later on. So next one, 2, 3, 6, 7. 10, 9. Okay. Predicted y's. Anybody have one?
Well, for us, we had 10, 0.
Oh, I told you to change 10, 9. Okay. That's all right, man. That's okay, Faith. All right. Anybody have some predicted y's? Predicted y's. Maddie, I see you got some predicted y's. What were they?
3. 6.3.
6.3?
Yeah.
Okay. And 10? Okay, so your line looked like this then? Like that?
Yeah.
All right. So what were your residuals?
0.
Okay.
0.7.
0.7.
And
Negative 1. So when I add those up, what do we get?
Negative 0.3.
Negative 0.3. Okay. Is that one closer to cutting the data in the middle?
No.
Okay, why was it closer, Maddie? You said yes. Why is it closer?
Because the dot is closer to the line.
Okay, so these dots are close to the line, right?
Yeah.
And these dots have, this one has one above and one
Below.
below. This one just had one above, doesn't it? So I kind of cut it on the bottom, didn't I? Right? If this were, let's say as an example, let's say it was a pie, right? Okay, this pie, I kind of cut it right there and said that was the middle, right? This one, if this is a pie, we're getting closer to that center now, aren't we? Okay, maybe we got an older brother, younger brother halves now. Okay, older brother, younger brother halves. You know what that is? So when you and your older brother split something, he always gets more.
Yeah.
Yeah, that's like a rule growing up. I was the youngest, so I always get the smaller half. All right. Thankfully today, one of my brothers is like 300 pounds now. That's right. All right. So go back to this. Predict y values. Okay. So what are my predicted y values here? Anybody have some?
5.
What'd you get, Jamara?
5.
5. Then what?
5.
5.
And 4.9.
5. 5. 4.9.
Yeah.
It does rhyme.
Wasn't it the middle?
You drew like a horizontal line, didn't you?
Yeah.
Yeah. Okay.
Where are we allowed to do that?
That's fine. So 1, 5. 3, 4. 5, 0. So your line looks like that, Jamara?
Yeah.
Okay. So what were your residuals?
0.
0.
Negative 1.
Negative 1.
Negative 4.9.
Negative 4.9. Now when I add those all up, what'd you get?
Negative 5.9.
Negative 5.9. So did Jamira cut her dad in half?
No.
No. Okay. If I were to have an ideal cut in half, what do you guys think my residual would be?
0.
Why 0, Faith?
Because that means the negative and the positive outweighs, so then it becomes 0.
Okay, so the positive residuals and the negative residuals would kind of counteract each other? Okay, would be at 0? Yovanique, why did you say 0?
Why did I say 0?
Yeah.
Because that would be the center.
That'd be the center?
Yes.
Okay. So that is correct. If we had the best line of best fit we could have, kind of redundant. If we had the best regression line possible, right, then our residuals would all add up to 0. Okay. The reason being, when my residuals add to 0, that means my line has an equal error above as it does below. Okay, I use the new word there, error, right? Means I missed the ones above the same amount as I missed the ones below. Does that make sense? So for this first data set, this green line was a great attempt, but it is not the correct line. Okay? But that person did what I asked. They drew a line of best fit like I asked. Right? And this is why drawing lines of best fit doesn't work. If I want to find the best regression line or the best line of best fit, we need to use our calculator. Right? We need to use our calculator to find an equation and then graph that equation. Okay, does that make sense? All right. So, for example, this one, a better line of best fit might be something that looks kind of like this. Right? So that these two residuals would add up to be the same as that one, so then they cancel each other out. All right? And we'll show you that later. But nice job on those. Okay? You have questions? Okay. So, what we're going to do now is we are going to figure out how to find the line of best fit for data. So if you flip your pages over, there's example 9. Okay, example 9 looks just like what? Looks just like the other page. Yes, Manny. Yes, it's fine. Okay. Or sorry, example 8. I misspoke. Okay, we need to find example 8. Example 8 looks just like the other page, right? The data points are exactly the same, right? So we are going to use a similar situation in talking about
Was there a window open?
finding regression lines. Yep, we're going to use our calculators this time. So we're going to actually find the regression line the correct way. It might, yeah, the back window's open. Jordan, you want to close that back window for me, please? Thank you, Jordan. All right, so we need to take out our calculators. You guys remember this is my calculator window, right? It shows what's on my calculator, right? And then here's my picture of a calculator. Because I'm going to show you the buttons. Okay? I don't like where that picture is located.
You want a picture?
Oh. You want a picture of a graphing calculator?
No.
I can post it on Facebook. You can make it your new background or something. You know, your new banner, or use it as your Twitter icon, right? Facebook's not as cool, huh? Falling out of style. It's bound to happen. All right. So what we're going to do is we're going to find the steps to finding a linear regression equation. We are going to learn the steps. All right, so on the front page of your notes, there's a box that says the steps to finding a linear regression equation. All right. The first step is you need to hit the button called stats. All right. Now stats. Oop, got the wrong picture up. That's why I got the calculator picture. All right. Stat is right here. So here's the little D-pad. Stats right there. Okay, right below delete. So you hit stats. Okay. Hit stat. And now, mine's still connected. There we go. Okay. So I hit stat, and now I get this page, right? Okay, I want to pick edit. And when mine pops up, you'll see that I have some data in there. Do not put this data in. Okay, we'll get to this data later. All right. So the first step was stats. Okay. And you want to choose edit. Okay, it'll be the first option. So it's really easy. You just basically hit stat enter. Okay. So stat edit enter. Okay.
Well, that would be interesting.
Does that make sense? Okay. Now, if you have list 1, list 2, great. you have L1 and L2, perfect. All right. If you are obsessed with clearing your data out, all right, hit the up arrow when you're below L1. Your cursor will pop up here. Do not hit delete. If you hit delete, it just removes this list. It does not clear it out. Okay. Do not hit delete. Hit clear. Okay. If I hit clear, then enter.
You gotta refresh it.
Then my list goes away. Okay. Same thing. But I do not need to do that. Okay. I can just punch in my data set over top of the other one. All right. So we're going to use that. We're going to use that first data set from example 8. Okay. So that first data set from example 8 was 1, right? 2, 3. So you punch in 1, 2, 3, hit enter each time. So 1, enter, 2, enter, 3, enter. Right? Right? And I go over to list 2, and if I put my x values in list 1, where do I put my y values? List 2, right? So we go over to list 2, and we enter our y values. What were our y values from that list? 1, 2, 5. That person's a good counter. Right? See how I can just enter it over top of the other ones? Okay. So that's our second step. Our second step was to enter the x values into list 1 and y values into list 2. And if you have your note page, your blue note page, there's a box on the front side of it, and all 4 steps are going to go in that box. Okay. Third step, probably my favorite step. Oftentimes overlooked. Now, last hour there was a debate whether or not you actually need to do this step or not. I always do this step because sometimes there are operations you'll do, and if I start typing in operations, it'll actually put it in this part of my list, and then it messes me all up. Okay? So I want to get out of this list. So how do I get out of this list? Second quit. Okay, now some of you might not know where second quit is. Second, the top left corner, different color. Mode, right next to it. Second quit. All right. So hit second, quit. All right, and the quit button is mode. Okay, I'll put that in parentheses. Enter in parentheses? Okay. All right, any questions now? Okay. Last step to find a linear regression. You hit stat one more time. Then you hit the right arrow. Okay? So stats. Oh, I didn't quit. There we go. Stat, right arrow. And what you'll see is a screen that looks like mine, if I can find my mouse. Where are you, mouse? There you are. Okay? You'll see a screen that looks like this. Okay? Now, this option right here says linreg. That is short for linear regression. That's what we want to do. Okay? So hit 4. Okay? So this step is to hit stats, right arrow, right? And that'll give us calc. And you want to hit option 4. Okay. Then if you have one of the newer calculators, your screen will change to something that looks like this. If you have one of the older calculators, you'll just see line reg and it'll have ax plus b. Okay? If yours says line reg ax plus b, just hit enter, and your equation will pop up. All right? If you have this type of calculator, this one's a little nicer, a little newer. It lets you check to make sure your x list and y list are correct. So it says, did you put your x list as L1? Okay, if I move that A, it's L1. Okay? Did you put your y list as L2? Right? Now the way you actually calculate your line regression now is you go down, you hit the down arrow until you highlight calculate. Okay? Once calculate is highlighted, come on, wait for you. Come on. Okay, it's not going to highlight. There it goes. once you highlight calculate and you hit enter, then it will calculate your linear regression. Okay? So I'm just going to write enter after this. If you have a newer calculator, if you actually enter 4 times, it'll work. If you have an older calculator, hit enter once, it'll work. But you have to highlight calculate and enter. And now what we've created is an equation. A linear regression. You might have learned it last year, but it's always good to go over it. Okay? So this is the way we create a linear regression. All right. Now looking at this, you might be confused. What goes where? I see an equation, then I see a bunch of different letters. Okay? Well, this is saying that A is 2. B is negative 1.333333. And there's this R value here. What's that R value?
Oh, that's the I think the R value show up.
We'll go through that one second. Okay. How do you get that R value? What's that R value?
Correlation.
Correlation coefficient. Good. This R value is our correlation. So instead of doing that big long Spearman's rank correlation equation or whatever correlation equation you're doing, all right, you can use your calculator. List 1, list 2, enter the data, make a linear regression, and it'll give you a correlation coefficient. Right? So this is a calculated correlation coefficient, not approximated. So is this strong or weak, Sandra? Wakey, wakey. Strong or weak? What do you guys think?
Strong.
Strong. Is the slope positive or negative?
Positive.
Positive, which agrees with my A, which is positive. So now, this equation is y equals 2x plus negative 1.3. All right, that's the equation. I plugged in for my A and my B. Okay, does that make sense? Okay. If you do not have the R value on there, and you really want the R value on there, right? You need to go through a quick process. You hit second, 0. Okay? So if I hit second, 0, I'll get a list of things like this. Okay? You can scroll down to diagnostic on, or you can hit button which says x negative 1. All right, has a D above it. And that'll take me to the list to the part of the list that begins with D. Then I need to go down here to diagnostic on. Okay. When I get to diagnostic on, hit enter. And this is really exciting what happens next. Hit enter again, it says done. So what this means is now my R value is on. Okay? So I go through stat, calc, 4 again. And hit enter, I go down and calculate. And hit enter and calculate. I get the same thing, and my R value should now appear. Any questions about that? All right. Now, we are going to use this equation to make predictions, right? So will it be good to have a rounded number here? No. So I want to figure out how to make that as non-rounded as possible. At negative 1.3, I do not want that rounded. Right? So what I can do then is I can type in negative 1.33333333 in my calculator. Okay? As many as you want. Okay, well not as many as you want, your calculator will keep going. But a lot, maybe 5 or 6. Then hit math. Frac. Enter. And now it tells me that 1.333333 is really negative 4/3. And now it went from an approximation to a fraction, which is exact. Right? So then my equation, either way works, is 2x plus negative 4/3. So now you guys have correctly made a linear regression equation. That is right in the glare. So any of you are choosing to watch this at home, I have a hard time seeing that equation. So does that make sense? Does that make sense? So some of you are probably thinking, what now? What did that give me?
You put it in the line.
Okay. So now if we go back to our example. Okay. We go back to our example. This is the data we just entered in here. 1, 2, 3, 1, 2, 5, right? That's the data we just entered in, correct? Yeah. So what this equation gets me is it gets me the best regression line for this data. Okay? So what do I mean by that? If I'm gonna real quick plot these points, the original points, I'm gonna plot them in black. So 1, 1, 2, 2, 3, 5. So those are the original points, right? Right. Now I'm going to use green for my predicted values. Oh, I wanted to zoom in first. I have to plot them again. Darn it. Oh well. Yep, this is example 8 on your notes. Give you time to catch up if you're behind. All right. Got to plot them again. 1, 1. Oh, black. That's green. 1, 1, 2, 2, 3, 4, 5, 3, 5. There we go. Okay, so I got my points, right? Okay. Now, to find our predicted y value, how am I going to find that? I don't have a line on there, do I? No. But I have the equation. So how do I find my predicted y? Plug what in, Maddie? What equation? What do I plug into the equation?
2x plus.
Okay, what did you say, Yovanique? The x value, right? So I have 2x plus -4/3. So this is my x value, right? So we plug that in here, and that'll give me my predicted y value. Okay? So we do 2x. Oh, wait, not an x. What am I plugging in for x?
1.
1. 2 times 1 plus -4/3. All right? So, well, so look at this. 2 times 1 plus -4 divide 3. Right? Hit enter. There's my predicted y value. Okay. Does that make sense? Okay. You guys see that? Okay. So my predicted y value is 0.6667. Right? Actually, let's use 460. And the 460 you'll see why later. Okay. All right, does that make sense? Guys, does that make sense? Okay. So let's do the next one. What do I plug into the next one?
2.
2. Which 2?
That's it.
The x. We plug in the x. I know it's the same number. That's why I want to make sure I'm telling you to plug in the x. So 2 times 2 plus -4/3. 2 times 2 plus -4 divide 3. So it looks like that. 2 times 2 plus -4 divide 3, right? Hit enter. What do we get? 2.6666666666. Keeps going. Right? So we're going to write 2.6666. Okay? We doing well? Yeah? Okay. And then the last one, what are we plugging in now? 3 or 5? 3. Okay. So 3, 2 times 3 plus -4/3. 2 times 3 plus -4/3. What is 2 times 3 plus -4/3? Anybody know? 4.666666. So you're probably saying, whoa, how do I plot those? Those aren't whole numbers. You just gotta try. All right, so let's try to plot. I'm gonna plot in green. So my predicted points, I'm gonna put up here in green, okay, is 1.6666666666, right? So I go 1, and then 0.666666 is less than 1, so it's somewhere down here. Right? My next one, 2.6666666666. So I go to 2, up to 2, and it's a little less than 3. About 2/3 of the way up. My last one, 3, 5, or not 3, 5, 3, 4.666666. So 1, 2, 3, 4. So it's right about there.
Where'd you get the .666?
Because this minus 4/3 was 1.3333333333, right?
Mhm.
So then when you subtract, you get 0.6666. Because this is 1 1/3, negative 1 1/3. So then I'm getting 2/3, 2 2/3, 4 2/3. Okay, but it's as a decimal, because that's what your calculator is going to spit out. So that's what we're going to use. Right? Because that's what you're probably going to use. You're most likely going to use the decimals, aren't you? Yeah. And you can write it as 0.7, 0.7, and 0.7 if you want to. All right, I'd be okay with that. If you guys rounded all those to 0.7, that'd be fine. Right? All right. So now, if you take your ruler out, which hopefully you grabbed, right? If you take a ruler out, I didn't grab one, someone grab a ruler, and you lay your ruler down, what do you notice about all the green dots?
They make a straight line.
Look at that. Straight line. Hey, you guys see that?
No.
Okay. So if I connect those green dots with a straight line, then what I've graphed is my linear regression. My actual line of best fit. Not my predicted one like you guys did yesterday. Your actual line of best fit. So that line right there, using a straight edge, is our actual line of best fit. Okay. If you want to. Now I said the residual, it has something special about it, right? So how do I find residual again? This is predicted, right? What's this one?
Y.
Actual. So residual is actual minus predicted. So 1 minus 0.666666666666. Try it out. It's actually 0.33333. Okay? Because this is 2/3, that's 1/3. 1 minus 2/3 is 1/3, right? Okay. Okay. 2 minus 2.66666666. What does that equal?
0.6666.
Positive or negative?
Positive.
2 minus,
But,
right? 2 minus 2.66666666. Right? So we're going to get negative 0.666. Maybe you're right. Your 6 is funny. Okay. Then we do 5 minus 4.6666666666. So what do we get? We do not get 1.
Negative.
5 minus 4.666666.
negative 1.
Nope.
Positive.
Guys, we have calculators. Just try to have a calculator instead of just
Negative
guessing.
3.
What is it?
Negative 3.666.
Nope.
Oh, negative 3.
No. You have a calculator, don't you? Okay. 5 minus 4.6666666666. What was it, Whitney? 0.3333, right? And it'll keep going. If I actually use the fractions, those decimals will go on forever. Okay? Now, what I say about residuals, if this is the true line of best fit, what's going to happen with those residuals?
They'll be 0.
They'll all add up to 0. So I want you to add these 3 numbers together. And do not forget the negative sign. You could. And what do we get? 0. So because the sum of my residuals is 0, what that tells me is that this line of best fits is the right one. This is the regression line. Okay? So we found the equation first, right, Andrea? Yeah. Then we plotted the points and connected the points to make my line. Right? We didn't just take a ruler and willy-nilly draw a line that goes through as many points as we can. Okay? And that's the big difference. If you look at your line of best fit from yesterday, you'll notice that your residuals, does it add to 0? No. And that's how I know that your line was not the correct one. Right? If the residuals all add to 0, or close to 0, because you might have rounded a little bit, if it's like 0.00001, that's close enough, right? It'll either be 0 or close to 0, and that means that you have the correct line of best fit. Are there any questions about that? Any questions? No one?